Science.
Okay. We know what mass is. Mass is matter. It is the stuff that stuff are made out of. That's what mass is. Mass is the matter. We know what volume is. Volume is the space. Volume is space that matter takes up. That mass takes up. Now, what is density? Density is the amount of matter, the amount of mass inside of a space. Okay? Inside of a space. And to give you a better illustration, I'm gonna go to the whiteboard. Okay, well, if we look at this and we were to pretend these balls are matter, are mass, okay? They're in a container and they fit pretty nice. The density isn't high because we have matter confined to a good amount of space. But if I make the space smaller, the density starts getting higher because we have a smaller amount of space fitting the same matter, but it's still smaller. And if we keep going, we get even smaller. The density keeps getting higher because we still have the same amount of mass, but it gets smaller, and the volume gets smaller and smaller. The space that it's in keeps getting smaller and smaller. So the density goes up. And this relation is shown by the fact that density is equal to mass, which is the amount of stuff, these balls, divided by the volume. Let's say, it was, but no, whatever. This makes sense. Okay? Because remember, you have mass, but you got a big space, so there's not a lot of pressure. And as the space gets smaller, these balls start to sort of push up against each other more. So the pressure gets higher. So the density is getting higher. And as the volume gets smaller and smaller, confining the space into a smaller area, the mass into a smaller area, the pressure sort of gets higher. These balls are pushing against each other even more. So the density is higher too. You can sort of think of the density as sort of the amount, it is amount of mass in a specific area. But it is also, you can also think of it sort of as pressure. And this works the other way around. If we were to have a big container like this, and we were to only have 4 balls, the density isn't high because, look, we have them, they're all spaced out. They're fine. But if actually I can just use the same container. If I were to add another ball, well, now this ball is pushing up against this ball. So the density is kind of getting a little bit higher. The pressure is getting up. And now these 2 balls are pushing against this one. And now this one, and this one, and this one, and this one. And we keep adding more mass, even though it's in the same size of the container. Since there's more mass pushing up against each other. That means the pressure, the force against each other gets higher, which means that the density will also get higher. Because if we increase the density, this number is going to stay the same, and we keep this number the same, this number is going to get higher. So the density will get higher. And just like this, if we lower this number but keep this number the same, the density will still get higher. The density will get higher. Oops, that was horrible. The density will get higher because this number is getting smaller. And it's a good way to think about it as the pressure within it by thinking about it like water, okay? Let's say we have some water molecules, right? Water molecules. We have 4 water molecules right here. And they're pushing up against each other. And let's say we have some rubber duck molecules. Let's say we have 2 right here, right? Okay, well, we have only 2 of these confined to the same amount of space. We have 4 of these versus 2 of these. since we're going to pretend like they're the same amount of mass, okay, this has more mass in the same space. See, this has only 2 in this space, but this has 4 in this space. So this has more mass, which means there's more pressure here, which means this is going to push up against right here with more pressure and force than this right here, than the rubber duck molecules right here. But if I increase the mass right here, that means more balls, more rubber duck molecules are going to be pushing up against each other, which means they're going to be pushing up against right here even more too. And since this is 6 and this is only 4, this is going to have more pressure than this one. So it's going to push it down. It's going to push against it. This one's going to push against this one. And this is called buoyancy. Whenever something in water floats, if your rubber duck floats in water, that's because your rubber duck, gosh, that's a horrible duck. Your rubber duck doesn't push against the water as hard as the water is pushing against it. And that's because your rubber duck is less dense. There's less mass confined in the same space. There's more mass in the water for the same space. See? Like in this case, the rubber duck has more mass in the same space. So this gets pushed up against this. But let's say if we put a brick in the water, if we were to put a brick in the water, then it would sink because it has more molecules in the same space. Let's say the water molecules are like 1, 2, 3, 4, 5, 6. But let's say the brick molecules are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has more water molecules pushing up against, it has more brick molecules pushing up against the water. So the water's not able to push it up. So the brick sinks because it's pushing the water down. And that's what we call buoyancy. And that's what density is. Density is the amount of mass in a specific volume, in an area. So it's mass over volume. Mass divided by volume. That's what density is. And it's a reason for buoyancy and why you float whenever you swim. So yeah, stay in school.